A couple of years ago, we were finalists in the Carbon XPRIZE competition, where we actually took CO2 from a natural gas power plant and we converted that into ethylene. And so that was the first time that industrial CO2 emissions were converted into ethylene. And since then, we've been working on refining the process. The way that we see it, because it's an electrochemical process, we'd be able to build out a module that's containerized. We can use that module to convert a certain amount of CO2, produce a certain amount of ethylene. And then to scale up, we'd basically just be building that same module over and over and over. And so we don't think that there should be too many issues with scaling that up. It's mostly kind of matching to the amount of CO2 you have, the amount of electricity you have available. That being said, the chemical industry is an enormous scale right now. And so in order to start making a dent in that, it's something that we do have to work and partner with companies to work and scale and deploy our technology so that we can start getting more sustainable chemicals into the value chain.
Hello, Alex. Thanks for joining us in Scouted Gravy. I'm very excited to have you here. How are you doing today?
Doing great. Thank you for having me.
When I was looking for startups which are working in chemical industry and trying to bring more sustainability into the picture, and that is when I came across CERT, and I found it very interesting of the thing that you're doing and what your website claimed, that we are producing green chemicals without using fossil fuel, and it's like much more sustainable process compared to other. But since I've read about it, I know about it. But for our audience, would you like to give us a small background or like brief description of what you are doing and what CERT is doing, what kind of impact you're planning to make?
Yeah, definitely. So the chemicals that we use, they go into like all the different sort of products that we interact with every day. I think something like 96% of all products start with chemicals in some form. The problem is that most of these chemicals are made from fossil fuels. And so there's a lot of emissions associated with their production. So what we're trying to do at CERT is we are trying to make some of these essential chemicals by using carbon dioxide as the source rather than using fossil fuels. So effectively, what we've done is we developed a process called direct CO2 electrolysis, where we take in CO2, water, and electricity, and we basically split that CO2 molecule, reform it into the same sort of chemicals that we would get from fossil fuels, but now they're actually carbon negative because we made them from carbon dioxide instead.
Usually, whenever I've read about startups which are using carbon dioxide to turn into fuels, they are mostly sourcing CO2 from other carbon capture systems or, sometimes direct carbon capture and sometimes even water-based carbon capture. So can you shed some light on how CERT is doing and from where CERT is sourcing water, electricity, and the carbon dioxide?
Yeah, so we're agnostic to where the CO2 is coming from. Our main technology is going to be the conversion piece. And so that means that we could connect to a point source from existing industrial sites. Some of them, even if we electrify them or change the fuel source, they're still going to be emitting CO2. So those are sources that we can use. We can also capture CO2 directly from the air and use that. In fact, we have a pilot running that we just recently started that is taking CO2 from the atmosphere and converting that into ethylene, which is an important chemical. Then in terms of the electricity that we want to use, obviously we need to be using clean electricity. Otherwise, it doesn't make sense to be burning fossil fuels to make that electricity. Fortunately, here in Canada, where we're based, we have a lot of clean electricity from hydro and the likes. And so as long as we have a clean electricity source, we can use that to run our process and make sure that we're making sustainable chemicals.
Okay. I think this is very interesting, and thanks for answering in such details. So Alex, my next curiosity is about, you mentioned that your core technology is the conversion process. So naturally you would want to, I think there's an opportunity in many industries, even in chemical manufacturing industries and aviation industry, where they would like to implement same technologies in order for them to produce the same green chemicals, or maybe just make their overall process sustainable. So I would like to know, if is the search technology, how modular it is, or maybe is it going to take them some, are there any challenges that they would face, or are there any modification they need to make to their system to implement the same conversion process in their value chain?
Yeah, that's a great question. And so one thing that we've been really paying attention to is, for a lot of these chemical processes, they use a lot of different equipment. They've invested a lot of money into them already. And so we want to make sure that we're not trying to replace the entire value chain. We have a lot of smart engineering to get to the final products that we want. And so what we're really doing is that conversion is making ethylene as our first target product. Ethylene is the most used carbon-based chemical in the world, and we have lots of processes to do it. And so we imagine ourselves sitting right at the front of that value chain, being able to take the CO2, convert into ethylene, and then we can feed that into the existing processes to make plastics, make fuels, and other sorts of important materials. But then those materials are now sustainable because we've put the same feedstock at the front we made it in a sustainable way.
Okay, I think that that makes sense. So, and has CERT tested it on, like, what is your views about scalability of the thing? Are you able to produce same level of quality, I would say, for the lack of better term, currently on a like industrial scale, or is there any challenge you see coming that your team is currently trying to solve, or maybe is planning to solve?
Yeah. So we have been working on scaling our technology. In fact, a couple of years ago, we were finalists in the Carbon XPRIZE competition, where we actually took CO2 from a natural gas power plant and we converted that into ethylene. And so that was the first time that industrial CO2 emissions were converted into ethylene. And since then, we've been working on refining the process. The way that we see it, because it's an electrochemical process, we'd be able to build out a module that's containerized. We can use that module to convert a certain amount of CO2, produce a certain amount of ethylene. And then to scale up, we'd basically just be building that same module over and over and over. And so we don't think that there should be too many issues with scaling that up. It's mostly kind of matching to the amount of CO2 you have, the amount of electricity you have available. That being said, the chemical industry is an enormous scale right now. And so in order to start making a dent in that, it's something that we do have to work and partner with companies to work and scale and deploy our technology so that we can start getting more sustainable chemicals into the value chain.
Okay. Yeah, I think makes sense. And of course, since this is a very new area, even though there's a lot of competition, but everyone is just trying to figure out how to make the technology work. So it makes sense that there is a small, I would say, not very long, but still long way to go. One thing that makes me curious is, and again, this is based on, like, I've talked to a few carbon capture startups which are either doing direct carbon capture or doing it from oceans or some other sources. In case of CERT, as you mentioned that you are CO2 agnostic, basically from wherever the CO2 comes in. Do you have plans on integrating with a set already established direct air capture technology, or is that something that you don't want to do and basically just focus on the conversion process only and not have your own direct air capture technology integrated into your existing systems?
Yeah, that's a great question. Our focus is definitely on the conversion part of it. I think there's a lot of great companies that are doing interesting work on direct air capture, developing new technologies. So we're not necessarily looking to reinvent anything there. More, we're looking to partner with companies that have good technologies, can either supply us with CO2, or in some cases, we can actually integrate even a bit more fully with certain direct air capture processes and actually make the process a bit more efficient by doing what's called a reactive capture approach, where we can actually generate the chemicals and regenerate the capture medium at the same time. And so that's something that we're exploring with a few different partners, but really our focus is on the conversion piece, because what we see is there's not that many options for making these sustainable chemicals right now. And so that's where we really feel that we have the expertise, we have the technology, and that's where we want to focus. As a startup, we have to stay pretty focused on a certain piece of the technology. And so that's what we're doing right now.
Yeah, it makes sense. That I was also about to say the same thing, that initially, you have to like stay focused on your USPs, and then it makes perfect sense. Yeah. So again, talking about the conversion process itself now, I've read, and please correct me because I'm coming from the outside of the industry, just based on like my few hours of research. I've read that mostly in electrochemical type conversion processes, there's a challenge that many companies run into, is that is like degradation of the materials and the catalyst you use and the electrodes you use. How is CERT addressing those issues? And of course, the electrodes will degrade if you use them and your conversion process. So how does that process looks like? Does it affect your overall costs a lot, or is there like, again, I'll share some context from where this question is coming from. If somebody wants to implement your conversion technology in this processes, they would like to know the overall maintenance and long-term maintenance cost of the system. So that's where my question is coming from.
Yeah, absolutely. And you're right. The durability and the lifetime of the system is really important, both for the economics and just how difficult it is to implement. And so that's something that we've been really focused on since day one at CERT. And so we put a lot of focus on the way that we design our electrodes in order to make sure both that they're scalable, but also that they're robust against the operating conditions that we have. We've also developed some processes that allow us to regenerate some of the electrodes in situ, so we don't need to like take apart the system and redo it. And so we've actually been quite happy with some of the tests we've run for in the thousands of hours, demonstrating that the system's maintaining its performance and continuing to grow. What we need is a bit more capacity to continue running these experiments, because it takes a long time to prove that they last a long time, right? So we just need to be able to continue running those, but we've been quite happy with the progress that we've made in maintaining the stability and the lifetime of these electrodes.
Makes sense. And I guess, I mean, yeah, this is something that it's not a problem of just CERT. It's like how the process works. Of course, everybody eventually industry will have move towards better, maybe electrodes or better way to manage these degradations. I guess then what makes me another thing that makes me curious, and of course I was thinking about this when I was reading about CERT, is that how does this, I would say, operational cost compares to, let's say, a typical where these companies currently might be sourcing ethylene from, or the other green chemical that they will be able to produce using CERT's system. So is there any comparative numbers? And of course, I'm interested in both cost as well as the carbon points they will save by switching to CERTs. So just want to do a balanced comparison of those things. Yeah.
Sure. And so at the moment, where we compare very well is against bio-based ethylenes and other sorts of chemicals like that. And so those are currently being bought for things like consumer-facing brands and for packaging and that sort of thing. And so we feel that we are very competitive against the biosourcing of these, and we have advantages in the greenhouse gas emissions as well. And then as we're scaling, our modeling has shown that we can get to about cost parity with fossil, and we could potentially go even lower if we're able to access, low cost electricity through intermittent use from renewables. Then that's something that we can even bring those costs lower. But then when you look at the GHG emissions from our process, or the carbon footprint, if we say made 1 ton of ethylene from a conventional fossil-based approach and compared it to CERT's approach, we could actually avoid up to 5 tons of CO2 for every ton of ethylene that we substitute. So this has significant effects if you kind of extrapolate that to the whole ethylene industry that gets up into almost a gigaton of emissions.
Crazy.
Yeah,
makes sense. I think that's a very healthy comparison. Actually, and I think on the website I read that it was like you end up using 3 tons of carbon to produce 1 ton of ethylene. And
that's
but
right.
yeah, I understand. Actually, you're not just producing it, but you're also offsetting it. That otherwise, fossil based ethylene production produces even more carbon. So I guess that works
That's
out.
right. Yeah. So we eliminate the emissions from the production of ethylene, which is typically 1 to 2 tons of CO2 for every ton that's made. And we actually sequester that 3 tons of CO2 into every ton of ethylene that we can make.
Again, it sounds amazing, and of course, I think these kind of solutions are very well needed in the industry. And so again, I'm happy to hear these numbers. So Alex, what I would say, like, a few last questions that I have, and this is one thing that I almost ask every founder, and it comes from my own personal curiosity, is that when I was reading about you, I saw that you have a very huge academic background, and you've worked in a university as well in the same areas, and there as well your interest was specifically into carbon capture. CERT is your first venture, is a commercial venture, right?
That's right. Yeah.
Okay. And being a first time entrepreneur, and again, this is coming from my talk to other founders, and I'm always curious about this. First time entrepreneurs, especially coming from academic background and innovating in an industry which is relatively new and very challenging. Even if it is new, it's also very competitive. Did you ever feel like that maybe the technologies you have, or maybe CERT system in itself, maybe this might not work, or maybe you will face challenges in scaling, or maybe this might fail? And of course, I understand every entrepreneur basically goes through these problems. So what I want to know is basically, how do you manage this, since CERT is your first venture? And of course, you must also think about these things, that what if this doesn't work, what if you face a bottleneck? So how do you sleep at night with those things?
Yeah, it's a great question. And of course, every day there's challenges. If it was something easy, then it would be already done by somebody and out and deployed. So we know there's still work to be done in order to completely prove out everything, so show that it works. I think coming from an academic background, I think part of what I enjoyed doing was looking at a problem that hadn't been solved, thinking of what are the ways that we can approach it, how can we build something new that can attack these problems. And so we carried that into the startup as well, myself and my co-founder Christine. So we spun it out, and it's a lot of the same things. What are the technical problems that we have to overcome? Really focused on doing that. And yeah, sometimes some don't work out. And so you either have to pivot on, certain aspects of the technology, look at different areas where maybe somebody has already solved it that you can take advantage of and not have to reinvent it. And so I think it's not that different in the approach, I would say. But I think one thing going from like an academic into a startup is kind of being a little bit more careful about like, in academia, sometimes you want to like solve every single thing before you think it's ready. I feel like in a startup, there's a bit of like you're fixing problems as you're moving forward on it and seeing where else you need to fix things as you go. So you're not necessarily going to solve everything, but you solve the most important things and just keep it moving and checking off the biggest problems off your list. The other thing is really being a lot more open to partnering and working with others in a startup. In academia, a lot of times you're on your own and you're kind of responsible for the entire project without any outside help. In a startup, I think it's important you find people that work on certain parts of the problem. You find partners that can provide you technologies that you don't have to reinvent, and being a lot more open to, how do you work together with other people? And I think that's to moving things forward at a good pace.
Yeah, I appreciate your such detailed answer, and I think that's a very engineering approach to solving this problem, which I really appreciate you sharing. I'm also an engineer from my background, but I'm actually currently working in marketing, so of course it's a different turn. But yeah, I agree, and I think what I see common in all the answers I've received so far is that you need to have a team that is able to do maybe that sometimes that you are not able to do, or maybe that is there to support you, and so it makes perfect sense. So yeah, Alex, I think that was all the questions I had. I mostly wanted to learn about CERT technology, backend technology, and basically how things are working, and I certainly got all my answers. Thanks for being so detailed and so brief about them. Yeah, basically that was it. Thanks
Great.
for giving me your time.
Thank you so much for having me here. Really, really enjoyed it.